We're going to continue our learning about the coordinate plane and graphing and take it into proportional relationships. So this is, of course, a coordinate plane. You can see quadrants 1, 2, 3, 4 made by the intersection of the x-axis and the y-axis at that very important point 0, 0, which we call the origin. We're going to be taking a look at proportional graphs, and that's that key word for this entire chapter. We're going to be looking at proportional relationships. And now, before we looked at what the definition of proportion was as far as they have a constant ratio between the two items, so they will always simplify down to the same thing. So that's one way we've checked them in the past, is to divide them and you'll always get that same number. Another way is to look at a graph of them. So these are the characteristics of proportional graphs. First of all, the graph goes through the origin. It has to go through the point 0, 0. That special point must be present if it's a proportional relationship. The graph is a straight line. In other words, can't be adjusting around in nonlinear ways. It can't be a curve of any sort. It has to be a straight line. The graph increases from left to right, which we will call a positive slope. So I always think about the way you read. We read left to right. And so if you're looking at this line, it is going uphill when you read it left to right. This line is going uphill when you read it left to right. That makes it a positive slope. Or when it goes positive on the x, it'll be going positive on the y. When it's going negative on the x, it will be going negative on the y. The last thing is the slope is the constant of proportionality. So we're going to look at these two right here. You see this line goes through the origin, is in a straight line, it's going positive. That is a proportional graph. Here's another one going in a positive slope through 0, 0, and it's in a straight line. Once again, a proportional graph. And we have a lot of information here. One way to check it is also with that constant of proportionality, which is the same thing. We'll deal with that constant of proportionality with a couple different ways, but here's one way to check it. If you will always divide it in this order, y over x. So let me take this relationship here. 9 divided by 3 is 3. 6 divided by 2 is 3. 3 divided by 1 is 3. Even if you go down to the negatives, negative 3 divided by negative 1 is 3. That constant thing right there is your constant of proportionality. The only one that will not give you 3 when you divide it is 0, 0, because of course you can't divide by 0. So we look at this other one. Let me do the exact same thing. Now I go 2 divided by 10. Remember, it's y over x, not x over y. So 2 divided by 10, if I simplify that, that's 1/5. 1 divided by 5 is already 1/5. Even if I go in the negatives, negative 1 divided by negative 5 is 1/5, excuse me, not negative 1/5. And once again, this one has a constant of proportionality of 1/5. Okay, that is also, we talked about plotting points being like the airplane, down the runway x, then taking off for y. Well, this is totally different. Remember, this was x, then y. When we talk about this slope, it's going to be what we consider the helicopter, because it's talking about the rise and then the run. So this 3 is actually a rise of 1, 2, 3, and then a run of 1. A rise of 1, 2, 3, a run of 1. A rise of 1, 2, 3, run of 1. Okay? And this one would be a rise of 1, a run of 1, 2, 3, 4, 5. Rise of 1, 1, 2, 3, 4, 5 on the run. Rise of 1, 1, 2, 3, 4, 5 on the run. And that's how we kind of count that. So let's take that and let's just try it a couple times, try to predict what I'm going to say. I have 4 relationships, this red, this blue, this green, and this purple, and we want to know which, if any of them, are proportional. So let's look at the red one. Is it proportional? Well, it's increasing in a positive slope. It is in a straight line, but what's its problem? It does not go through the origin. So is this one proportional? No. Let's look at the blue one. The blue one does go through the origin, so that's a good point. Problem is, we have several problems. First of all, it's decreasing or has 0 slope at some points. And is it linear? No. It's not linear because we have a strange jog in the middle of it. So once again, blue, in this case, not linear. Or not, excuse me, well, not linear and also not proportional. Let's look at the green one. The green one goes through the origin, goes in a positive manner. It is linear. Guess what? That one right there is proportional. Let's look at purple. Purple also is going in a positive slope, but however, I can already tell it does not go through the origin, so it is not proportional. So really, the green one was the only one that we had that was proportional there. That term that I used earlier, constant of proportionality. We're going to use this and tie it to a couple things we've done. First of all, it is the unit rate. We've done unit rate a number of times, right? How do we find unit rate? Well, we put things in a ratio, and then we do what with them? Divide them. Guess what this is? A ratio, and then we will divide them, making x then become 1, because that's really what a unit rate is when the bottom is 1. And remember, it's y over x. In other words, this is the helicopter, not the airplane. It is the slope, rise over run. Remember, rise, y, over run, x. Difference of y, difference of x, of a proportional relationship. And it is the coefficient of x in a proportional relationship. We're going to look at what a proportional relationship looks like as an equation. It basically looks like this. Y equals 7x. Because remember how we talked about there's not going to be any addition or subtraction. There's simply multiplication. So guess what that is? That is the coefficient of x in a proportional relationship. That 7 in this case would be the constant of proportionality. It could be a fraction. Constant of proportionality. If I put a plus 1 there, it is no longer proportional because we're not going to have any addition subtraction on there. It's going to be a straight multiplication relationship. And the last place that we're going to be looking at that constant of proportionality is if we happen to have an ordered pair with 1 as the beginning, then guess what that star is? That is your constant of proportionality, because if we go back to this y over x, think about that. That would make that star be right where the y is, and x would be 1, and isn't that the unit rate, which is our constant of proportionality?